All right, so we're going to go into solving compound inequalities. So here we have two different inequalities for each problem, and we are connecting the two inequalities with an or and an and. As you can see, in between part A, the two inequalities there, we have or. In part B, we have and. We'll see how that comes into play when we determine the solution for each of these. Now, what we want to do first, as you can maybe guess, is we want to solve each inequality individually. Okay, so we would first divide by 2 for the first inequality. And we would just get x is less than 5. Okay, so that tells us that we that for just the first inequality, any value that is less than 5 will satisfy the first inequality. But we still need to solve for the second inequality, so let's do that. So we would subtract 1 from both sides of the inequality, and we get x is greater than 8. All right, let's carry down this or. We still have or. So what we've determined is any value that is less than 5 will satisfy the first inequality. But to satisfy this whole, what's known as the compound inequalities, we determine that any value that is less than 5 or any value that is greater than 8 will work. Okay, so what does that really mean? Well, what I like to do is to express your solution graphically and then see where they intersect. And keep in mind we want set builder notation in the end, so we will want to determine what that looks like. So let's go ahead and look at each of these individually graphically. So x is less than 5, and graphically we would be up at 5. 1, 2, 3, 4, 5. And it would be less than, so it would look like that. In this direction, and it would be an arrow pointing that way. Okay, and then x is greater than 5, or greater than 8. I like to keep the same scaling, so we have 0 and 5, and then we would just be up at 6, 7, 8. All right, and that's greater than, so that's 8, and we're graphing to the right. Okay, so now what do we mean by or? So either one, so it just has to be in one location. To determine what x is less than 5 or x is greater than 8. We want to graph that now. What would that mean in our final solution? It would have to be in either one. Or. So 5, 8, 0. Okay, so it has to be in either one. It doesn't have to be in both. It has to be in either one. So what we need to do is just figure out where either one is located, which will actually just be the ending graph of and this. So it has to be in at least one of the two inequalities. So there we go. That is or. X is less than 5 or x is greater than 8. Now, it is possible that you don't just have the combination of the two and you're done. But you will end up having the combination of the two just appearing like this if the two different intervals do not intersect. As you can see, they do not cross over each other at all. So it's just simply just copying them down in the final result. Now we want set builder notation. So as we can see, our final solution is just this right here that we want to put into the set builder notation. Now they use this union symbol. So one way of writing this is x, vertical line, x is less than 5, union, the set x, vertical line, x is greater than 8. Now, this is called union. That is the symbol that represents OR. This is OR. And we ended up finding out when we graphed it that this is actually, it just ends up being the two intervals put together. So we have x is less than 5, or sorry, vertical line, x is less than 5, or x is greater than 8. All right, so we can do the same thing with the part B, but we're dealing with AND. So let's go ahead and make a separate video for this, and I'll keep this up, but just to split it up, I'll make a separate video.